Okay, multiplying polynomial expressions. So yesterday we focused on a monomial, which means what? One term. Polynomial means multiple terms, right? Because I said it's the umbrella, so it could be a monomial, a binomial, a trinomial, or more terms. So polynomial is multiple terms. So we did one term by 2, 3, 4. It kind of just depended on the problem. Today we're going to focus on at least binomials and then on. So binomials, trinomials, polynomials, on. Okay? There are two methods that I'm going to show you. You can choose the method that works best for you. I don't care which one you do. One gives you a little more organization. The other one, you have to organize it yourself a little bit more, but you do you. Okay? So the first method is just going to be distribution. First method's going to be distribution. Second method is the box method. So again, I'll show you both, and then we can decide. Sometimes you might use the box for certain problems. Sometimes you might use distribution, and that's okay. It's the same thing. It gives you the same answer. It's just a different way to organize. And I'm actually going to start with the box. So we are going to look at the problem x plus 5 times x plus 2. So we're going to do this problem twice so you can see both methods, and then we'll decide as we go through. So x plus 5 times x plus 2. How many terms do I have in this first set of parentheses? 2. How many terms do I have in the second set? 2. So my box is going to be a 2 by 2. Okay, 2 rows by 2 columns. So we're going to create a box. That's literally a 2 by 2. So 2 rows, 2 columns. Now on the outside of the box are my polynomials, in this case my binomials. It doesn't matter which one goes along the top and which one goes along the side, but I'm going to write x plus 5 along the top. That's a positive 5, so x plus 5 along the top. And down the side I'm going to do x plus 2. Okay. Y'all have taken biology? Yeah. What does this look like to you?
Punnett square.
So same thing. Okay, to get in the box, you multiply. What is x times x? What's x times x? X squared. X times x is x squared. What is 5 times x? 5x. What's 2 times x? 2x. And 2 times 5? 10. Okay, so to get in the box, we multiply. To get out of the box, we combine like terms. Do you notice where our like terms are? The 5x and 2x. Your like terms in a box, if you have them, will always be the diagonal. Okay, sometimes there's not like terms, but if there are, they will always be at a diagonal. So to get in the box, we multiplied. To get out of the box, we're going to combine like terms. Is there anything I can combine x squared with? Nope. So I have x squared. 2x plus 5x is 7x. And then I have the 10 at the end. Are we okay with that? Okay, so you can create a box. To get in the box, we multiply. To get out of the box, we combine like terms. Or we can distribute. So if we're going to distribute, which we will for this one, so you can see the difference, we're going to take the first term in our first box and multiply it by both terms. I said box. First term in our first set of parentheses and multiply by both terms in our second set of parentheses. So what is x times x? X squared. What is x times 2? 2x. I'm going to do the same thing with the second term in my parentheses. I'm going to multiply it by both terms in the second set. 5 times x, 5x. Now I can write it all the way out, but I'm going to stack terms, like terms, on top of each other so that I can just add down. Even if you don't want to use this method, I want you to write it down so you have it. So everyone should be writing. And then 5 times 2 is 10. So now my like terms are on top of each other, and I can add down. I have nothing to add x squared with, so I'm going to keep x squared. 2x plus 5x, 7x. And then I have my 10. Okay, you end up with the same answer because we're doing the same thing. It's just a different way to organize it. Just off the top of your head right now, if you had to choose one, how many of you would choose distribution? Okay, which means everyone else is in the box method. Okay, so I may go back and forth just to kind of, so you can see both, but you do whatever one works for you. Okay, let's do number 2 together, and then I'll give you one to do. Okay, since most of us want to use the box, I'll use the box method for this one. If you don't want to use the box, you don't have to. How big is my box going to be? 2 by 2, right? I have 2 terms in each. So I'm going to draw a 2 by 2. And I have a 2x plus 4 along the top. Again, you can put that along the side. It doesn't matter. And then I have x plus 3. If I multiply in, what's x times 2x? 2x squared. X times 4. 4x. 3 times 2x. 6x. And 3 times 4. Do I have like terms? Yes. Check the diagonal. And then rewrite. So I have 2x squared. 6 plus 4 gives me 10x plus 12. We okay with that? Not too bad? Okay, so remember, when you're multiplying, that's when your exponents are going to change. You add exponents. When you're combining like terms, you just add or subtract the coefficients. You think you can try one? Yeah? Okay, so let's try x plus 2 times x squared minus 5x plus 4. So I'm giving you one that's a little longer. If you're choosing to use the box, how big is your box going to be? 3 by 2. So you can do 3 rows, 2 columns. You can do 3 columns, 2 rows, but you're going to have a little bit bigger box if you're using the box method. If you're distributing, you don't have to worry about the box. So I'll give you a few seconds, well, a few minutes to work on that. Okay, I'm going to use the box just so we can look at what it looks like, but it's 2 by 3. I like to go 2 rows by 3 columns because it takes up less paper going down. But yours can be the other way. Like if yours is like this, that's okay too. All right, along the side, I have x plus 2. Along the top, I have x squared minus 5x and 4. This was the biggest question I had. X times x squared. So I have 1 here and 2 here for a total of 3, x to the 3rd. 2 times x squared is 2x squared. X times negative 5x is negative 5x squared. 2 times negative 5 is negative 10x. X times 4 is 4x. And 2 times 4 is 8. Do you see your like terms? Do you see that they're in the diagonals? So your like terms, if you have any, will always be those diagonals. X third, I have nothing to combine with. 2x squared minus 5x squared is what? 2 minus 5. Negative 3, and then x squared. Negative 10 plus 4. Negative 6x, and then I have my 8 at the end. How'd you do on that one?
Good.
Good? Okay, I'm going to give you 2 more. You choose the method. Okay, you choose the method and solve. I'm going to distribute for number 4 just so those of you that are distributing can see it. Those of you that are not distributing can see it a different way. Okay. All right, so number 4, if I distribute this 3x, I get negative 6x to the third plus 15x squared minus 18x. If you did the box, that should be the terms in the one row of your box or column, depending on how you set it up. You should have the exact same terms. If I distribute this negative 4, I get 8x squared minus 20x plus 24. That should also be a row in your box or a column, depending on how you set up your box. So when I combine like terms, I get negative 6x to the third. 15 plus 8 is 23x squared. Negative 18 minus 20 is a negative 38x plus 24. How'd you do? Good? Okay. This last one, again, box or distribute, it doesn't matter. If I do a box, how large is my box?
3 by 3.
A 3 by 3. Okay, so this is where my box gets larger. Doesn't matter because they're both have 3 terms, so I'm going to put the first one on top. Whoops. 2x squared, 3x, and 1. And then I have an x squared, a minus 5x, and 7. If you're distributing, you're going to have 3 rows that you're going to have to combine, right? X squared times 2x squared is 2x to the 4th. X squared times 3x is 3x to the 3rd. X squared times 1 is x squared. So far, so good. Okay. Next row, negative 5x times 2x squared is negative 10x to the 3rd. Negative 5x times 3x is negative 15x squared. Negative 5 times 1 is negative 5x. Last row, I have a 14x squared, a 21x, and a 7. Where should my like terms be? Diagonals. So I have the x to the thirds. I have the x squareds. And I have the x's. 2x to the 4th. Negative 10 plus 3 is negative 7. X to the 3rd. 14 minus 15 is what? -1. -1 plus 1, 0, so the squareds go away. 21 minus 5, 16, and then I have my 7. Did we get that one? Awesome. What questions, comments, concerns do you have? Nothing? We're okay? All right.